I would put this down on your notebook paper. We are going to be writing an equation of a line given 2 points. This slide and the next slide that we do are just review from Math 1 and middle school things that you've done. So hopefully these first 2 slides that you have is just a review from previous data. I have some U-tries in today's lesson, but because of picture day stuff happening, we're going to cut out those U-tries, so there may be some slides that I jump through rather quickly in today's lesson. So our problem here says, write the equation of a line given these 2 points. Well, first off, when you think about equation of a line or linear equation, what's the first thing that comes to mind? Good. Y equals mx plus b. That is perfect. That's what we want to use to write our equation. We're going to find the numbers for m and b and plug those in. Now, first, let's talk about m. M is your what? Slope. There's an equation for m. We talked about it last week, but it's the y2. Good. Y2 minus y1 over x2 minus x1. That is how we start these equations. We're going to start off by using that equation to find our slope between these 2 points. So remember, you can label your equations as x and y. So the first one are x1, y1. And the second 2 are x2, y2. So let's just plug those values into our equation for slope. We're going to do y2 minus y1. So 1 minus -3. Then 7 minus -4. So always keep a minus in the middle and then keep the sign that's with the number. So that's why on the bottom it's 7 minus -4. And then we simplify as much as possible. What's 1 minus -3? And what's 7 minus -4? Good. Whatever you have here for slope, you always want to reduce it as much as possible. Can I reduce 4 over 11? Nope. But maybe make yourself a note. Always reduce slope. So you want to always reduce your slope. Now we are going to use that slope and one of these points, it doesn't matter which one, and we're going to plug it into our equation y equals mx plus b. So we're going to plug the point in for y and x and a slope in for m. That's going to help us solve b. Now, again, it doesn't matter which point you use. I like to deal with positive numbers, so I'm going to use the second point. So in the place of y, I'm going to put 1. My slope was 4/11, and x was 7. So 1 equals 4 over 11 times 7 plus b. Now let's solve that for b. First step, multiply these two together. So grab your calculators out. Don't forget all fractions need to be put in parentheses. So what's 4 over 11 times 7? 28 over 11. Now, our last step is to get b alone, so we're either going to add or subtract whatever is with b. So we've got this 28 over 11. It's positive, so we need to subtract it. And don't forget it's a fraction, so put it in parentheses in your calculator. That's just a good habit to get into. So on each side, we subtract 28 over 11. So what's 1 minus 28 over 11? That sounds good to me. Now remember, your final answer is the equation of the line. So the equation pulls in what you have for b and then what you get for m, and you write that as an equation. So it would be y equals 4 over 11x. And then it's plus b, but since our b is negative, go ahead and just put minus 17 over 11. And there we have our final answer. So y equals 4/3 x plus 17 over 11. Or minus 17 over 11. I said plus, didn't I? Oopsie daisy. All right, let's try another one. So write down your next 2 points. If you want to label them, go ahead and label them. I like to call them x1, y1, x2, y2, because remember they're coordinates, so they're x, y. And then let's start with our slope. So m equals y2 minus y1. So in my numerator, I would put good job. That's exactly right. So y minus y over x minus x. The second minus the first. So what's negative 3 minus negative 2? Negative 1. Oops. Sorry. I was thinking in my head and I said the answer. What's 8 minus negative 2? 10. Now, negative 2 over 10 can be reduced, right? What can that reduce to? Negative 1/5. If you're ever unsure, type it in your calculator and hit math enter. So you want to evaluate the numerator first, then the denominator, and then simplify. All right, next we're going to take our equation, y equals mx plus b, and we're going to plug in for everything except for b. So you need a point for y and x. Again, you can use the first or the second. Which one y'all want to use? The second one? Okay, so negative 3 would go in for y, negative 1/5 for m, and 8 for x. Again, it doesn't matter if you use the first point or the second point, but make sure you use the same point. That's key. Now, first we multiply. What's negative 1/5 times 8? Negative 8/5. And that one makes a pretty good decimal. If you left it as a decimal, that is perfectly fine too because the decimal ends. It didn't on the last problem. Now let's solve for b, so we need to. We're going to add 8/5 now because it's negative, so we're going to add it to both sides. So let's do negative 3 plus 8/5. Negative 7/5. And then a final thing that we want to do is write it as an actual equation. We found m, we found b, so y equals negative 1/5 x minus 7/5 because it was another negative number. Do y'all remember doing this a little bit back in, it might have been middle school or it might have been last year, but good. This is something that, don't lose this paper. This is really important because you're going to be doing this work again when we do our roller coaster project, which comes up second quarter. So about October, November-ish, you're going to be doing this again, okay? So don't lose this paper. There are other ways of finding slope. The other equation for slope is rise over run. So if you don't want to use this equation that we have here, you can use rise over run, but in order to do that, you have to graph the points. So if you want to use rise over run, you have to show me that you graph the points and then just count up and over for that slope. I like to use the formula if I already have just points, but you can plot them on your graph paper and count. That's fine too. All right, so I said we'd have a U-try, but we're not going to try those. We're going to move on to some graphing. We're going to graph one line at a time. So everybody start with writing down this first equation on your graph paper. We're going to come back to notebook paper at the end of class, but we're going to start with our graph paper. In order to graph, they need to be in that format y equals mx plus b. Is this graph or this equation in that format? Yes. So since it is, we pick out our m, which is always the number with x, which stands for our slope, and we're going to treat this slope as rise over run. So anytime you're working with a graph, you want to think about rise over run as your slope. So this slope is 2, but we could put it over 1 to help us graph. So if you have a whole number, put it over 1 to do that graph. Then this number, this 3, is called our y-intercept, and it's the b. So b equals 3, which is also our y-intercept, which is where we start on that y-axis. So we always start with b. It's the y-intercept. We started there on our y-axis. Then we use our slope to make more points. So which one's our y-axis? The one going up and down. So first, draw you an xy axis. It doesn't have to be drawn really big, maybe 5 or 6 lines or 6 grid marks. And we are going to start at a y-intercept of 3. So I'm going to move up to 3, and that's where I start. So that's where I put my first dot. Then use your slope as rise over run, and we always run to the right. So rise, run, right. So I'm going to go rise 2, so up 2, and right 1. Up 2, and right 1. You can also do it backwards. So instead of going up 2, right 1, you could go down 2, left 1. And once you get a few points, draw the line, or something close to a line, through all of those points. And that's how you graph. Dun, dun, dun. Thank you. Thank you very much. Do y'all remember how to graph a line? Does that make sense? It's been a while. Let's try our second equation. Go ahead and write down the second one then. Your lines are looking pretty good. What do you know about this equation? Can I graph it like it is? No, what do I have to do with it? Solve for y. I got to get y by itself in order to graph it. So first thing we need to do is minus the x. We got to move x over to the other side, so we're going to minus that x from both sides. So we get 2y equals, now I like to put my x first, so that way it looks like y equals mx plus b later. So I have a negative x and then that minus 4. So you move x over. Okay, what's my next step? Divide 2, and we want to divide everything by 2. So y equals, what's negative x divided by 2? What's another way of writing that? Good. Remember why we did that the first day now? Remember I told you that the first day, x over 2. All right, so we get negative 1/2 x, and then what is 4 divided by 2? Negative 2 or minus 2 there at the end. Now this is something that I just like to do, and if you want to do it to help out, you can. But I like to write down what is my slope and what is my y-intercept, and then I make my graph. So my slope on this one is negative 1/2. It's always the number that is with x, and then my y-intercept is negative 2. So that's the number that doesn't have x with it. So if you ever write yours in the wrong order, what is with x is slope, what is by itself is y-intercept. So now draw your xy axis. Your y-intercept is at negative 2, so I'm going to go down 2 and start. Remember, that's your starting point where you put your dot, and then use your slope from there. But if my slope is negative, can I rise negative 1? Nope. Which way do I go? Down 1 and then still right 2. Down 1, right 2. Down 1, right 2. So remember, when you start, always run to the right. If the top number's negative, you go down. You can also do it backwards. Instead of down 1, right 2, I can go up 1, left 2. If you remember from Math 2, our first day in Math 2, we talked about how many points you need to make a line, and you actually only need 2 points to make a line. But the more you plot, the better your line looks. So plot a few extras. All right, that's all the review I have kind of from Math 1 and 8th grade math is how to write equations and how to graph a line. So now we're going to move on to, it's more a review for Math 1, but it's how to solve a system of equations by graphing. So systems means more than one. So we're going to graph a line, and then we're going to graph another line, and guess what we're going to try to find? Where they intersect, where they cross at. You're exactly right. So here is our next problem. So write down that one. If not, it's on the list. I forgot to print it. All right, good thing about these two problems is they are what? They're already y equals, they're ready to graph. So what's the slope of the first line? -2, and we could put that over 1. Anytime it's a whole number, I like to write it over 1 to remember my rise over run. And my y-intercept is 3. You can go ahead and graph that one without doing the other line. So if you want to go ahead and plot some points there for that one and make a line, that's no problem. So y-intercept is 3. 1, 2, 3. So start at y equals 3, and then we go -2, 1. So that means we go down 2, right 1, down 2, right 1. If you wanted to go backwards, you can, up 2, left 1. Once you have several points, let's graph the second equation. What is the slope of the second equation? And our y-intercept. Good. So now when we graph this one, we're going to start at our y-intercept of -2. So start -2, make a dot there on that y-axis. And then slope is 1 over 2, which means we go up 1, right 2. Up 1, right 2. Your goal is to see where they cross or intersect. Once you see that, you can stop. Now, it looks like they intersect at an exact point. What is the exact point where it intersects at? Perfect. 2, -1. On the first 8 problems of your homework, you're doing things like this where you're graphing 2 lines. So I want to see not only the 2 graphs, but also the intersection point. I'm going to do a little extra with you guys. You can check your work. Let me show you how to check your work by hand, and then I'll show you on the next problem how to check with a calculator. If you wanted to check your work by hand, you're going to plug in your answer for x and y to make sure it works. So is -1 the same as -2 times 2 plus 3? Does that equal out? Well, what's -2 times 2? Plus 3. Check, that works. So I plugged it into the first equation, and now I'm going to plug those same numbers into the second equation to make sure that it works. So what's half of 2? And 1 minus 2 is -1. So check that works out as well. So if you want to double check your answer, you take your point, plug the x value in for x, the y value in for y, make sure it works out. Quick way to kind of double check and make sure you have that answer. So plug it into both equations. All right, our next problem is already up there on the right. If you want to go ahead and write those two equations down. Tell them. 10:35. All right. Yeah. Yes, you can. Okay. Now, what do we have to do on these two equations? Can we graph them like they are? Nope. Let's solve them. That's right. You got to solve them for x. So I'm going to take that top equation and just write it to the side and now get x by itself. What would I do to get x by itself? Or, sorry, y. You're right. I got to get y by itself. So I would minus x. Set it backwards. So 2y equals negative x plus 7. We minus the x, but the 7 was positive. And then the next step, divide everything by 2. So y equals negative 1/2 x plus. Now, here's something that I like to do when I do these problems, especially if I'm going to graph on graph paper. I leave my my slope as a fraction, but your y-intercept, you're going to be plotting it on the graph. Does it make sense to leave it as 7/2? No, it would make more sense to say it as a decimal, right? So 3/2 is what as a decimal? 3.5. So leave that y-intercept as a decimal and leave your slope as the fraction to make it easier to graph. So if I were to go through and graph this problem, it has a y-intercept of 3.5, so I'm going to go up 3 and then halfway, so I'm going to be right there in the middle. And then my slope is negative 1/2. Now you want to go down 1 unit and over 2 units. So if you go down 1, you're still halfway in between. So you're staying halfway and then going over 2. So that's what the graph of that one will look like. Start at 3.5. We go down 1 to 2.5 and then over 2. Down 1, over 2. All right, let's take our second equation, 2x minus 3y equals 0, and solve for y. What would I do to get y by itself? Minus the 2x on both sides. So negative 3y equals negative 2x. Now, because you have a 0, you can leave the 0 off if you want to, or I sometimes like to just put plus 0 in there. It's just a plus, or just a placeholder. It's not going to change anything. You can leave it if you want to. All right, and then my last step is to and divide every single thing. So y equals a negative divided by negative is a positive 2/3 x. Plus, what's 0 divided by any number? 0. So you can put plus 0, or again, you can leave it off. I like to put it because I like to see it on my graph. So if I start to graph this, my slope is 2/3 because that's the number with x. If there's nothing added on or if it's a plus 0, then that is my y-intercept. So remember, if there's nothing, it's also just your y-intercept. Now, where is a y-intercept of 0? At the origin. We're going to start at 0, 0. If there's nothing there, start at the origin. And then we're going up to over 3. Up to over 3. Now, it looks like these two cross where? At 3, 2, right? Are we sure? Can we double check? Yes, we can. So there are two ways to double check. We could do it like last time where we plug the numbers in, but let me show you how to do it on your calculator. So everybody grab your handy dandy calculators. And we're going to have to make a graph, so we're going to have to type it in. Y equals. Now, you cannot type your equations in how they're given to you. You have to solve them for y first. So make sure that you solve for y and then type in those equations. So the first one was negative 1/2 x plus 3.5. And the second one was something. Whoops. 2/3 x. And again, you can put the plus 0, or if you leave the plus 0 off, that's fine. It'll work the same way. So once you have your two equations typed in, go ahead and hit graph, and you'll see your two lines graphed. Does everybody see the same picture? If not, let me know. Okay. So your calculator will find this intersection very quickly because that's what we want. So hit second trace. And what option do you think we're going to use there? That's right, option 5, intersect. Now the only thing I ask you to do, you don't have to do this every time, but move your cursor close to the intersection. It doesn't have to be on top of it, just move it close and then hit enter 3 times. And it tells you your intersection is at 3, 2, which is what we said. So let's write down those calculator steps so that way you have them. So maybe up here to the corner, calculator. I'm going to keep it simple and we're chanted to remember it. Second trace 5, enter 3 times. Obviously, make the graph first, but then hit second trace 5, enter 3 times. Second trace 5, enter 3 times. Or get Luke to come in with his guitar and make us a song. So, solve the equations for y, put them in y equals, graph them, second trace 5, enter 3 times. Again, this is a way to check the answers. You can do it if it's like a multiple choice question or if I don't say show work. But if I say graph on graph paper, you're graphing on the graph paper, you write the intersection point, you can check with the calculator. All right, we've got one more graphing problem to do. I don't know if y'all can handle it. It's a tough one. Not that one, that one. This one actually gives you the answer, but you still have to make the graph. Now, we did these back in Math 2, especially in that translations unit, but does anybody remember what y equals 1 looks like? What kind of line is that? Almost the other way. That's it. Y equals our horizontal lines. So if y equals 1, we're going to go to where y equals 1 and we're going to draw a horizontal line through all of those points. Because at all of those places, the y value is 1, right? 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1. Good. So what is x equals then? Vertical line. So we're going to go to -4 and draw a vertical line. Oops. And what's my answer? -4, 1. So it actually tells you the answer that is -4, 1. That's where x is -4, y is 1. Put those together, make two lines, and these lines intersect how? Perpendicular. That's a key word. So if you have perpendicular lines, they're going to have one solution. You're going to have where they cross one time, and like this one crosses at -4, 1. Now, let me give you a little helpful hint on this as well. If you are taking a test or a quiz and you forget which one is which, remember your calculator does y equals. It doesn't do x equals, but it does y equals. So if I just type y equals 1, I see it's a horizontal line. So that means x equals has to be vertical. So if you forget, that's a way to check. And then there we have our answer. So the first 8 problems of your homework are like this. You graph a line, you graph another line, you put where they cross. But there are some special types of lines, are there? Like lines that don't cross. What kind of lines are those? Parallel. So that's your next question. Write down these 2 questions. Save about 3 or 4 lines. Thank you, Wesley. Do you have any questions? No? Okay. So write down this question, save 3 or 4 lines, and write down the next question. All right, so we said what types of lines never intersect. Those are parallel lines. You guys already know what parallel lines look like, right? Draw them in there for me real quick. That's right. There are 2 lines that never cross and never touch. They're the same distance apart. If you end up having parallel lines, you still graph them. What is your answer? Good, no solution, because these never cross. So on your homework, I want to see the 2 lines graphed, and I want to see you write to the side, no solution. Now, what makes lines parallel? Think about the equation. What in the equation will make them parallel where they won't cross? They have the same slope. But they do have to have something different. What has to be different so that way they don't cross? The y-intercept. So when you solve the equations, I'll just put an example right here. It could be like 2x plus 1 and 2x minus 3. That would be 2 lines that are parallel that don't cross. Again, on your homework, you still graph the lines, but your answer would then be no solution. All right, we've got one last question. What type of lines always intersect everywhere? They're what? The same line. And what makes them the same? Well, that's if they have the same slope and the same y-intercept. So an example of that is like y equals 2x plus 1 and y equals 2x plus 1. And it may be that you don't see it as y equals 2x plus 1 until you start to graph. Now, if you graph on your notebook paper, you're going to graph one line, but I would just make that line a little bit more thicker, like make it look a little bit more solid. That way it looks like one's graphed on top of each other. And what would the answer be? IMS, because it's the same line, it hits everywhere. So you still graph, although you only graph one line, and your answer is IMS. Your homework is technically a worksheet, but I forgot to print it, but you don't actually need to write on it anyway, so it is online on Canvas. I'll pull it up here on the board as well, so that way you can see it. Again, the first 8 problems, you're going to graph on graph paper. Make sure you write the intersection or no solution or IMS. The next 4 problems, you're writing the equation of a line, just like our first 2 examples in our notes. And the last 4 problems are multiple choice. You don't have to show any work for this multiple choice if you don't want to. You could do these 4 on your calculator or use the picture that's there. You got a lot of options that you could use. All right, any questions? All right, go to work.